Okay, thanks everybody. We're going to get started, so if you could please take your seats. This is our third session, and I'll be moderating today's business panel discussion on cutting-edge applications, problems, and solutions associated with the use of drones. Our speakers today include Eric Taipale, Chief Executive Officer and co-founder of Sentera, Aaron Lessig, CEO and Chairman of Pulse Aerospace, and Eileen Lockhart, who leads Xcel Energy's Unmanned Aircraft System program. So let's have each of you take about 5 minutes to introduce yourself and your expertise in unmanned aerial vehicles.
All right, well, thanks everybody for being here. My name is Eric Taipale, and I am with Centara, which is local here in Minneapolis. Do I need? Yep. Oh. So I'll give you just a 5-minute overview, a little bit about our company and the markets that we serve and the areas in which we're active today. Basically, the core technical team emanated from Lockheed Martin. We built several thousand small drones for Lockheed Martin over the past 10 or 15 years. I started about 20 years ago with unmanned aircraft, and I've grudgingly decided that drones is an acceptable term. But the aircraft were very large. It was the predecessor to what's now the Predator A and the Predator B aircraft. So my personal background was in precision targeting, remote sensing and precision targeting. And as the technology progressed, the platforms and the sensors got smaller and smaller to the point where we're at the technical stage where we are today. But we're about 25 people. Through a kind of entertaining series of moves, we became an independent company and were spun off with our intellectual property and formed Centera about 2 years ago. We were very fortunate to secure about $8.5 million of Series A funding to go and take our know-how and our IP and target that at the commercial space, which is really just starting to emerge a couple of years ago. So we're active in 3 broad markets. We're active in infrastructure inspection, agriculture, and in the public safety market. So just to give you an idea of the scale at which Centera is operating, our equipment has photographed more than 25 million acres of land, mostly innocent corn and soybean plants. 25 million acres since we began operating, and that number rises dramatically now every month. That's about 15 million individual photos that we're storing and managing on behalf of our customers. 5 of the 6 largest enterprises that are providing agronomic advisory services in the United States are our customers, where we're managing the ingest or the management or the downstream processing of precision agricultural imagery. And we have users all over the globe. So I'll talk a little bit about what it's like to be in this business. It's the parallels to the adoption of unmanned aircraft on the military side, the challenges, the foolish assumptions. We were very fortunate to make all of those mistakes once, and so we're at least making them more quickly this time around. It's quite a different business, but basically we're trying to do things that are straightforward and simple for our customers to understand. And we're being very careful to go into each of the verticals and to attempt to understand the value streams that already exist. And we're coming in with drone technology as a way to do something faster, less expensively, but really non-disruptively. There are value streams that are very complex in all of these industries, and our job is really not to go in there and make people think we're going to take away their jobs. Our job is to go in there and make them think we're going to give them the input data that they need more quickly and more easily. So one thing that I will keep coming back to, we learned this very early on, the robot airplanes that fly are really neat for just a couple of weeks, and then people really don't care. They're there to solve a problem. And drones, as interesting as they are the first time you see them, to me, I'm an electrical engineer with a remote sensing background. It's a camera or it's a sensor that's hanging in the sky at a very precisely known location, and we're going to accomplish a task with it. The robot airplane part goes away incredibly quickly, and customers have a problem that needs to be solved, whether it's in agriculture or in telecom. And the way to make money with a drone or in anything else is to answer that question as efficiently and as quickly and as inexpensively as possible. And we try and stay very focused on that. We get away from talking about airplanes and sensors and processing very quickly, and we get into what the customer is trying to accomplish with this system. And we are quite agnostic. So sometimes you see I brought a white DJI Phantom 4. You can go buy that in the Apple Store or at Best Buy. We put a little sensor on that turns it into a vegetative health platform. But it's very common for us to provide solutions that don't use our hardware at all. They might just use our software. When we go build a sensor, it's generally just because it's not commercially available elsewhere, and that tends to be at the higher end of the market. So just very, very, very quickly, I brought a Phoenix. That's the black airplane for those in Minneapolis that are in the back of the room. It's pictured here on the left. That's a fixed-wing drone. That's the only drone that we still nose-to-tail design, manufacture, and provide ourselves. We also make a wide range of sensors, ranging from very simple vegetative health, 28-gram sensors that clip on to DJI Phantom consumer-grade hardware, all the way up to very high-end precision survey and mapping, imaging, and LiDAR-based sensors that are used on much larger drones. Aaron's going to talk more about those types of platforms, I believe, as well. And then finally, the most rapidly growing portion of our business is in this generic term software, and that is really the core of the issue for most of our customers, which is that once these things get out there, they produce tremendous amounts of data. We'll produce about 10 gigabytes of image data per hour that we have the aircraft in operation. And when that scales to hundreds of drones flying over thousands of fields, it becomes an absolute nightmare if the tools aren't there to organize and make it available for downstream processing. And that's really emerging as now the core and most rapidly growing part of Centera's business. So this is a pretty picture on the right. This is an NDVI map of one of our customers' fields. This is a snapshot of what the most basic data product that we provide from a drone is. This is a 40-acre field, and it took us about 45 minutes to generate this product, including the flight time. Basically, red is bad and yellow is good. And this is a data product that, because Landsat, satellite imagery, has been around for so long, this NDVI, which is a vegetative health index product, it's very well understood by the agronomy community. We're just simply providing that on demand when the user wants it. Doesn't matter if it was cloudy, doesn't matter if the satellite's not scheduled to fly over. We can do this within an hour or two. And like I said, very well understood product to inject into a current value stream. So there are some really amazing things that this type of thing enables, not just drones, but drones working in concert with a lot of the other things going on in precision agriculture. There's an opportunity to dramatically cut the inputs, the fertilizers, the pesticides, the herbicides, and still raise yields. And I think you're going to see those things emerge with drone, ground, and other technologies over the next 5 years. It's very near-term things. So that's a brief introduction, and we'll look forward to your questions.
All right, thank you, Eric. My name is Aaron Lessig. I'm the CEO of Pulse Aerospace. Just to give you a quick background, Pulse Aerospace is really focused on the control and automation and optimization of UAS. So really what we do is we take military-grade capabilities and we press that down into the commercial markets at a relevant price point. So as we see, our competitors either moving from a military position, trying to move into a commercial market, we can match that control capability. And then as we see more of the commercial grade systems, or excuse me, consumer grade systems, trying to move up into that commercial market, we feel that we're in a good position to beat them on capability. Just to give a little bit of background, Pulse Aerospace comes from an aerospace heritage. We're about 15 years old, and like I said, focused on UAS automation and controls. We started out really working more with military systems and large R&D platforms, Department of Defense, DOI, Department of Energy, et cetera. And then about 30, 40 of the largest research universities in the United States. And out of that came this capability to take a existing platform or to design new platforms in an optimized way that extend performance. So we're generally getting anywhere from 2 to 5 times the endurance and payload capacity of our competitors, and that's all based around how do we control that system, how do we optimize it. Today we're working in many, many parts of the world. Australia, we're heavily focused in mining. We're doing some interesting work on looking for sharks, believe it or not, which I thought was kind of a silly market until I found out that it's over $100 million market. And we worked in Death Valley, and I say here, Kansas, exclamation point. If you've been to Kansas and you've experienced the weather and the wind, it's no joke. So we're all over the place. So when I really look at the marketplace and where we focus, this is a kind of cumbersome slide, but Pulse really looks at the bottom part of that platform or pyramid. So if you can't optimize a system, if you can't make it perform well, then you can't get into some of the more advanced capabilities that the market's pushing towards. So as we look at infrastructure inspection, as we look at mining, as we look at interfacing with machine control, if you can't carry relevant sensors for a relevant amount of time and then begin to react to what those sensors are seeing and perhaps just collect the data that's necessary versus all the data, then we feel that that's a disadvantage. Most of the market today is focused on the data and analytics piece, which is absolutely necessary, as Eric said. If you get information and you don't know how to use it, it's worthless. But that's not our expertise. We partner with the analytics experts and the data providers and give them more data, better data, and then ultimately allow them to more autonomously collect just relevant information. So this is kind of the value stack as we see it. We see the operator in the market that's already becoming commoditized to an extent. That's in terms of the value chain, we feel that that's going to be experiencing considerable pressure quickly. And then once again, on the far right side, the analytics and the business decisions, those are often inherent to the businesses that we're working with, as Eric mentioned. They know what they want, they know how to analyze the information, or they have existing analytics platforms they want us to tie into. So when we look at going and getting information, once again, it's all about getting accurate and precise information. Some recent highlight projects. Pulse was the first commercial UAS provider in the United States to do gas leak detection. We did the first beyond line of sight utility inspection in the United States with a very well-known utility company and a third-party contractor. We're working with the Department of Interior. We have that contract on the UAS side. Last December, it was an interesting project. We delivered 12 pounds of blood and medical supplies 8 miles away to a third story of a rooftop building for the Special Forces, and then flew back. And then once again, we're doing quite a bit of work in Australia. So moving into this beyond line of sight market, which we think is going to be critical to driving value, we've got a lot of experience there. So those are just some photographs of our systems. On the left here, you'll see a Vapor 55 with the gas leak detection system. On the right, this is our Shark Watch vehicle, one of our Shark Watch vehicles in Australia, where our helicopter is actually replacing the manned vehicle and flying out looking for sharks or swimmers in distress and dropping buoys, et cetera, in the water for those swimmers. If you saw some of the photographs that we're getting, you would probably not get back in the water. It's pretty intimidating. On the utility side, as I said, we conducted the first beyond line of sight utility line inspection, LiDAR inspection, and then we just recently started doing lead line pulling, where we can actually help with new construction of systems. And then on the bottom right here, this is about a 5 square mile ash dam in Australia that we mapped. Photographs of our 12-pound beyond line of sight delivery. So all of these things are really early stage work, and I think we'll hear from Xcel also that this is a learning process. The market doesn't always know what it wants, and so as a technology provider going into those situations, there's so much opportunity it becomes difficult to really hone in on what's most valuable. And really, I think we're getting to that point today where folks really understand once you get past the shine of a robotic flying vehicle and you get back to what Eric said, which is collecting valuable data. I feel like we're finally getting there, which is an important place to be. So I'm going to skip through this because I'm talking too much, but this is our Vapor 55. This system is being used extensively in mining, infrastructure inspection, agriculture, as well as general survey. So moving into kind of more specifically the ag market, we are not primarily an imagery organization. We take advantage of the control side. So one area that we're filing patents in is around the interface of automated spray and flight control, which will obviously drive UAVs into a much larger system size. So these are some examples of payloads. We can hot swap payloads. So one mission, you may carry cameras. The next mission, you need to carry LiDAR. The next mission, you need to carry hyperspec, et cetera. We can really give a lot of flexibility to our customers to go get the data that they need to drive value. So thank you.
Okay, Eileen.
Yes, good morning. Can everybody hear me?
We can.
Okay, thank you. So good morning, everyone. I'm Eileen Lockhart. I am the UAS program manager for Xcel Energy, and I basically oversee all UAS operations and develop strategy and governance around our program for Xcel. And a little bit about my background, I'm the co-founder of the program, and Xcel really started looking at this technology back in 2013. So we'll get into the details. If you want to go to slide 1, please, that'd be great. So just a little bit about Xcel Energy. We operate in 8 states in the Midwest part of the United States. And as you can see from our territories, it's extremely diverse culture as well as diverse environments and weather. So we inspect over 320,000 miles of infrastructure a year, both gas and electric. And with that amount of infrastructure, that comes a lot of challenges. So particularly in our service territories. So if you want to move to the next slide. So when we heard about UAS a couple years ago, it was very intriguing. I can say, as from an end user perspective, we're always looking to improve our inspections. We're always looking to improve how we do things. And so when UAS really became part of the market, we wanted to really investigate how we could use that from a utility perspective. So back in 2013, we started testing phantoms and smaller applications inside our boilers and our generating facilities. And we found very quickly that this was very promising. Some of our boilers in our generating facilities are 20 plus stories tall, and we would have to either have our employees climb up scaffolding or ladders, or to inspect this piece of equipment, or do rope propelling. So it was extremely dangerous. So the thought of having a flying camera go into our boilers and really get good detail on those pieces of equipment was extremely attractive. Once that happened, we were able to not only significantly improve our employees' lives and safety, but we were able to save a lot of we were able to save a lot of money. So in 2014, I co-founded the UAS program for outdoor applications and created a small team across the company to really take a look at the value proposition or the business case. Where should we use UAS and how? And really understand what the market looked like. Back then it was pretty new, and there was a lot of regulatory restraints around using UAS for commercial operators. So we really wanted to kind of get a read on the industry, and we partnered with several organizations across the country to help us determine if we wanted to move forward with this technology. So in 2015, we did decide to go ahead and become a commercial operator for UAS. And at the time, the FAA required commercial operators to apply for what they call an exemption, or a Section 333 exemption waiver, which basically allows you to fly at a certain altitude for commercial applications. So we did that, and then once we were able to get our certification, we really started to dive into research and development, or proof of concept missions, across our operating territories and across our operating services. So I'm going to move to the next slide. So this is kind of a little bit about our approach, how we decided to make this work. A little bit of history. There's various different ways to use UAS. One is within the visual line of sight. So as long as the operator can see it and control it, they can perform very basic inspections. The next one is beyond visual line of sight. So if you want to fly 20, 30, 40 miles to inspect infrastructure, that's the type of capability that you need. But in order to do these, the FAA is very adamant on proof-based performance. So, we determined that in order for us to really embrace this technology, not only did we have to prove to the FAA that we could do it, we had to prove to our organization that it made sense and we could do it as a company. So my team, we developed a series of proof of concept missions across our operations and really started chipping away at using this unmanned aircraft system technology. And after we executed these missions, we found it very, very promising, and now have a full program office with a dedicated team to really use this type of technology. Do you want to move to the next slide? So just a little bit about the missions we've completed. From a utility perspective, our employees have very, very dangerous jobs, so and diverse jobs. So we decided to try to touch every operating area within our company. The first mission that we conducted was actually within our transmission organization, and it was in energized substations. And to give you an example of what this looks like, our employees, have to work within energized substations on a regular basis. And this particular task they had to accomplish was to get facility rating data on the equipment within the substation. In order to do that, you had to basically back up a bucket truck into the energized sub, and then the person would have to get into the bucket truck and hold either a hot stick or a camera stick and try to, either using a mirror or a camera, get to the piece of equipment that had a nameplate about this big, where it told you the ratings of the equipment, the manufacturer, the year, things like that. And we are required to report that for various regulatory compliance and FERC requirements. So very dangerous job. Our first proof of concept mission was to eliminate that and use a UAS, a small UAS, to fly within the sub and get really high resolution imagery of those nameplates. So it turned out to be a very good success. So that kind of gives you an example of some of the applications. Another one on our transmissions in our transmission organization is we did line inspections. And, we have thousands of miles of lines that need to be inspected on an annual basis. And traditionally, we either do that by foot or we deploy helicopters. And so what we wanted to prove out here was, could we use a UAS, an unmanned aircraft systems, to do the same job? And actually, we've partnered with Aaron and some other folks to help us with those inspections, and it proved out to be a very safe operation. On our gas side, we also did pipeline inspections where we both performed a high-pressure pipeline inspection as well as a distribution pipeline inspection. And what was interesting about this was we simulated a gas leak in our high-pressure pipeline system and used UAS and the proper sensor to see, could we get the right readings? Could we see that leak? And in fact, we could. So again, the promise of UAS within utility applications is very real. A couple other ones that we've done are wind turbine blade inspections. I love this story because, we have many, many farms. In fact, Xcel Energy is the #1 wind provider in the United States. And I partnered with one of our wind turbine engineers and said, okay, let's try to do an inspection of our wind turbine blades using a UAS. So he went out and picked the most perfect turbine he could find in his farm, thinking that there was absolutely nothing wrong. And we flew a UAS and actually found significant delamination on the blades, which would have caused, significant cost to repair. So he was surprised to find not only the damage, but the high resolution that we were able to acquire using a UAS. So as Aaron has indicated, we're learning. There are hundreds of applications for UAS within the utilities infrastructure, and our job really is not to replace the man or the helicopter, but really just to enhance the data that we need to report to our regulatory bodies, and really provide a good, innovative tool for our employees and help improve their safety. So that's kind of a little bit about our company. Happy to answer any questions you may have.
Okay, thanks, everybody. Moving into the discussion portion of the session. So these questions can be answered by any of our experts, and just to give us to tee up our discussion, can you just provide some different uses where UAVs are being used right now?
Yeah, I can start. This is Eric. So I guess, like Aaron said, when you're providing a new technology, one of the things we learned about our customers is that they are a lot more creative than we are. So there's kind of a mainstream use case where today we have a really nice partnership with John Deere, where through the John Deere dealer network, people can buy essentially a turnkey system from a Centera turnkey system through their dealer network, and they get an iOS app, they get a drone, and they get a data subscription, and they can go out, they can push a button, and John Deere has an enterprise platform that downloads all of the field boundary definitions, all the geolocations of the field boundaries, and they pull up our app, they select their field, they push a button, it goes and flies, and it pushes the data right back to John Deere or right back to their agronomist. That's a really straightforward use case that gets down to basically the push of a button, and there is very minimal safety and airspace awareness training for a drone operator on top of that. In a little more esoteric case, we deployed this technology which basically allows you to fly a drone, take pictures, and then get a really good management tool that's verifiable around where the images are. So we have one customer that's tracking turtle nesting habitat in the South Pacific. We have a kangaroo wildlife refuge in Australia that's using our technology to map the location of kangaroos not sure about the privacy implications for the kangaroos or not. But what we've learned is that we attempt to kind of standardize on some very straightforward, well-understood problems, and then the customers take these tools and they go do whatever they want with them. And it's one of the most fun and rewarding parts of being in this industry.
Well, I would answer that a little bit similar, but also there's kind of a first step in my mind as well, as we get approached by a lot of folks that are wanting to use these systems for things they just shouldn't use them for. And so we're trying to kind of pull some folks back and talk a little bit more about risks for some of these missions that they are creative, but they're also, and sometimes they're not appropriate. But in terms of what we're doing, and we've talked about it a little bit, infrastructure, oil and gas pipeline inspection, utility line inspection, and we just finished a MERC and a FERC inspection using LiDAR and also photogrammetry. Shark watch, looking for sharks. Mining applications, that's actually a really big one for us, where we're being used almost 24/7 to go out and map in centimeter type resolution what's going on within the mine, so that they can use that to drive work orders. But we're looking at now machine controls and interfacing with the machines so they can use that information to actually drive the equipment itself and get to full autonomy. On the delivery side, large payloads for medical applications within the military. We are working with the Navy and Special Forces on some pretty interesting humanitarian response type applications as well. So it's really endless, but what's interesting is that you start in one place and you end in another, and along that process you really discover what's valuable, you discover what makes sense, and sometimes it's has nothing to do with where you started.
Yep, I would agree. So how I would respond is, from a utility perspective, I had mentioned that there are hundreds of applications where we can use UAS, and really what we're focusing on is how do you get the most bang for your buck? What is the most worth use cases out there for the utility, for our customers, and for the industry? So one mission that I did not describe was we are now looking at using unmanned aircraft systems for emergency response and storm disaster and natural disasters. We experience several outages a year due to storms or some sort of natural disaster. So we've partnered with some agencies up in North Dakota and are executing what we believe to be the first natural disaster proof of concept mission using a high altitude aircraft and a low altitude aircraft to really assess the damage on our system. So, we're simulating scenarios. We're simulating a storm and building scenarios and seeing how we can use this technology to assess the area and then prove out the integration, the data integration back into our control center. So the thought is that we will deploy a high or a low altitude UAS, get a very good assessment of our damage. We will be able to get that information real time, and then we would be able to generate a list or almost like a product list of what we need and deploy our crews to get the lines back on so our customers can get their power back on quicker than we can today. So that's another application that we're looking at using unmanned aircraft systems. I would say there are several that are like that are very unique, but kind of like what Aaron suggested, we get calls all the time about, can I fly a UAS and hang a flag around the city of Denver and do marketing? So it's pretty comical, some of the use cases that are coming out that are either appropriate or not. So.
Okay, in view of these various uses, how will the newly implemented FAA rules change the way UAVs are used, And other than these rules, are there other sticking points that are preventing you from using UAVs for any application you can imagine? And in addition, what are your thoughts on maximizing the utility of UAVs while still ensuring safety?
Sure.
Take that, yeah.
Well, I think from my perspective, much like the end user, I believe the FAA is as cumbersome as it's been. If I was in that position, I would do it the same way they have. So, you don't want to go out and run before you walk, and certainly nobody wants to have something bad happen. So I think this has been a good process to get us to the point where we are today. Our customers and end users, the first thing that comes to mind is what data can they get, but then that's replaced quickly by how do we do this safely? And so I think from my perspective, where we are today is probably a good place to be. Next steps, I would like to see the FAA be more aggressive in opening up rural applications and learning there first before they move into anything that the population may interface with. One of the other sticking points, I think, is when we look at ultralight aircraft and some of the vehicles that aerial applicators on the agriculture side that really live in the airspace that we're operating in, that gets pretty difficult. Today, they're not required to carry transponders, so it becomes difficult to communicate with them. I think having a standardization and regulation around how some of those ultralight or maybe low altitude vehicles communicate with UAS, I think that's probably the biggest hurdle I see in terms of being comfortable as a technology provider, and then lastly, I would say that there seems to be a lot of application that is offshore or potentially like a rural situation where the FAA maybe should allow that to happen a little bit more quickly. So that's my take.
I'd say, as a person who's both a pilot and as someone who's worked in the aerospace industry and dealt with certification through the FAA and through the U.S. Navy or through the DoD, I'm kind of amazed at how quickly they moved and how aggressive they were. And I think it actually is an example of a very good process that went relatively expediently. I can't look at Part 107 and say that structurally I would do it a whole lot differently. I agree with Aaron. It's fundamentally saying that we expect people to understand how the airspace works. We expect people to exercise responsibility in terms of putting equipment into the air. But beyond that, there's really broad latitude in the operator exercising that knowledge. And I think they did a good job. And based on my experience with the FAA, it was lightning speed. So I think they basically did a good job. I would say, we deal with some fairly large brands at our company as well, and I might almost reverse those priorities and say that their concern is primarily about safety and liability and not wanting an association with a negative event that involves a drone. And so we are probably primarily focused on those messages and on engineering around that type of operation even before we're demonstrating business utility. And certainly in aerospace, when aircraft with people goes into it, we talk about things like triple string avionics, 3 autopilots and any 2 voting carry the day. That is not the case with most of the consumer grade drones. They're what we call single string. There's a highly reliable processor, but there's only one. And for me, that means I would never put that architecture above a crowd of people. I would never do it. And until the commoditization of highly redundant avionics gets to that point, they won't be over people. And so I think it's prudent to architect things that way. And there will be a set of applications that just aren't going to be realized until those types of safety considerations can be addressed properly. But having said that, there really is, we can see a very clear runway to keeping every engineer that we can possibly hire for the next 10 years busy just doing the things that really are enabled today and making them
Right.
smoother and more tightly and more cleanly integrated into workflows.
Yeah, yeah, I would agree. I don't want to, I mean, I agree with both of what you said. I support the FAA. I think their approach was spot on. They, like I mentioned before, they are very much interested in proof-based performance. They're a safety organization, and from my perspective, Xcel is also a safety organization. So we're not going to jump into something before it's not 100% developed. So, I don't want to restate what these folks have already said, but I agree 100%. In terms of a sticking point, I mean, I guess my sticking point would just be that many we're ready to use this technology, and we want to be able to find the right vendor or partner to help us with the various components of using this technology. So if it's from an operator perspective or if it's from a data storage analysis, I guess that's the hardest part from my perspective, is really, knowing who your partners are, trusting their credentials, and making sure that their platforms or their product is certifiable. And the FAA stands behind those applications, I would say, is a big sticking point from the utility perspective. But we applaud the FAA for their approach on Part 107. I think it absolutely makes sense to require business case justification for things like the online of sight and night flying, and in terms of flying around people. I know that the FAA has partnered with CNN to really figure out how they can use unmanned aircraft systems for news reporting. So, I kind of agree with their approach. So.
Okay, thank you. Moving on, with respect to UAV technology, do you see problems with UAVs that need solving to increase their compliance with the FAA rules and or their efficacy in commerce?
Well, I'll take that one and I'll start off. From my perspective, the biggest problem that I have is picking the platform. There are thousands of platforms out there that claim that they can do all kinds of amazing things. And, when we're an operator, we want to be a credible operator. We want to be a safety organization to really figure out which platform you need and what sensor and at what resolution. That is a big barrier for us. I think it also is a barrier for the FAA because it's extremely overwhelming, and they want to be able to certify any sort of product that they want to be able to stand behind their platform and their product. So, the process of certifying these kinds of platforms and sensors, I think, is critical for the industry to really prove out the worth and build trust among the industry. That's what I think is one of the big ones for compliance. The other one is, from our perspective, we have to perform certain areas of work for compliance and regulatory reasons. So if I don't have the backings of my local CUP's office or our regulators, and if they don't have the information that they need to trust the applications that we're using, then we won't be able to use that kind of technology to enhance our safety and employees' performance. So to me, that's a big barrier from my perspective.
I guess from my perspective, I would echo that. I think getting to the point where the FAA can recognize the difference between different architectures of controls and safeties within the UAS is key, and I believe they're starting to do that. in terms of efficacy, efficacy always goes to use and really understanding what you're trying to solve before you go do it. So that's more of an end user piece, I think, than the FAA. I think there's probably some technology issues there more than regulatory, because there's plenty of commercial applications that exist today that we can drive with current regulation and technology as it stands today. So I think it's just picking the right application and executing.
And I agree with both of the previous comments. I would say I'll speak more about the efficacy. When we worked on the military side, and I know Pulse has probably had similar experiences, we understood what the chain was. We called it the sensor to shooter chain for obvious reasons. But we were producing a data product, and we understood where that information was going to go and how it was ultimately going to be used, no matter what the application. I will say that we do a substantial business in mobile telecom inspecting towers, which have many of the same dangers. It's very dangerous to climb a tower just to go look at something. And we do a lot in precision agriculture. Once we delivered this data in real time, we kind of thought there would be tools that existed that would be there to further exploit it and come up with answers. And that was probably a fairly naive assumption, given that these data hadn't existed in the past. But we were frankly stunned that once we could provide this data, there was not a whole lot to be done with it in an automated fashion. And so I think that to realize the value of the raw data that are being produced by these systems, right now there is a mad rush, as Aaron said, to develop automated analytics that can look at a plant when the plant is 2 inches high. That's never been possible before on a broad scale. Or to go look at a piece of equipment hanging off of a tower and automatically identify issues. That's coming, but that's going to be over the next 2 and 3 and 5 and 10 years, and it's going to creep in incrementally. And that's when we'll realize the full value, is when we can do more value-added processing around a lot of the problems that these verticals face.
Yep, for sure.
Right, okay, well, so moving along, on UAV industry intersections and contrasts, how does the use of UAVs differ or overlap across industries, and are the legal concerns the same or different across these industries? In addition, are there unique challenges or opportunities that are presented because of these different industries where UAVs can be used?
I'll take a shot at it. I would say we've started the whole use case development, and we partner with various organizations across the company, as well as other utilities across the company, and we all converse on a regular basis. And from what I've seen, I would say that the use cases are fairly similar in the sense of inspection. What the type of inspection obviously differs, but we're all trying to see something, inspect something, assess something. So I guess from that perspective, there's significant overlap. Where it becomes different is, the type. If you're dealing with sharks or energy infrastructure or plants, or trying to determine the health of something, that's where it really gets interesting. I've heard a couple things on insurance. People want to use UAS for insurance. They want to use it for real estate, and so it's frankly overwhelming. But I would say that they do significantly overlap, but the end product is relatively different. I'd be interested to hear what the other panelists have to say about that. In terms of legal concerns, there are significant legal concerns, at least from my perspective. I want to make sure my employees and my customers are safe. We're not trying to spy on people. We want to make sure that whoever we use or whatever we're doing is credible and certifiable. And there are several legal concerns that are generated with that. And frankly, they're new. You know, we haven't had to deal with this kind of imagery or data or concerns. So it's a new space that we're trying to learn and understand. And I think from a utility perspective, all of us across the country are trying to really embrace that and trying to understand the legal ramifications. If somebody were to hit our line or vice versa, what do we do? What is the risk assessment? Things like that. And I guess just from a legal perspective, it does pose a tremendous amount of challenges and concerns and discussion and really thinking about it outside of the box. You know, just from a contract perspective, there are numerous of different things that we've had to really analyze and think through that we haven't had to do so before. You know, the IP is a big issue that I see everybody in the industry is having to deal with. You know, there is a mad rush on who's going to be the first for this type of application or this type of software or whatever. So, you know, I would definitely say legal is a big concern, not only from the utility perspective, but from the FAA's perspective and everybody that is engaged with the UAS. So, but I'm interested to hear what the other panelists have to say.
But I would say that, I mean, I think the use cases in terms of operationally, you know, if you're looking at kind of broad acre mapping, those are all pretty similar, whether it's agricultural, construction, things like that. Really goes back to the type of sensor you're carrying, and we're getting pushed more towards heavier payloads, so which we like because that plays to our advantage. But you know, we're seeing a lot of demand for kind of manned aerial quality sensors, so 15, 20-pound sensors, which we like. But in the end, the big difference is going to be, as Eric said, how do they use the data that they get? And then that kind of falls more into the business that he's driving. But I do believe that operationally, there's kind of two pieces of the puzzle in my mind, and this goes also to legal, but within line of sight, which is I would say a lot of the construction, agricultural type applications where you can get a lot of useful information and drive that back to a decision within line of sight. But in some of the things that Xcel's working on and oil and gas or big mining companies, they need to go beyond line of sight, and that requires technological differences. Can you follow the terrain? Can you what happens if you lose data link and you're 10 miles out? So we like that we're getting to kind of experiment with some of these things in Australia and other countries that have some clarity around that path, because we get to bring that back to the U.S. and start to help our end users understand what we're learning elsewhere. And so I would say that goes to both the challenge and the opportunity for my organization, where we really do focus on control architectures. We really do focus on, you know, how do we network data that's coming off a UAS in real time to provide a enterprise solution. So we like those opportunities. We like hard stuff because that really separates what we do from more the consumer grade system. So we like hard stuff.
Yeah, I'd agree. And as an American company in the drone business, you have to like the hard stuff because the easy stuff is being answered in other parts of the world right now. So I'd echo that. I would say there was really strong commonality across all of our verticals for a while, where everybody just wanted RGB pictures, and then they wanted to know when and where. And the precision around the when and the where of kind of visual imagery was a common denominator. But now, as the uses have become more sophisticated, we're doing things like multispectral and hyperspectral sensing, where it's not just even specific to agriculture, but it's specific to a particular region that might have a particular issue, where we have a custom sensor, or we have thermal imaging being applied in a very different way in agriculture than we do it in infrastructure or in military and public safety. So there's been a huge kind of, it's not even a bifurcation, because it's going in multiple directions, where the specialization around specific problems by industry has become much more pronounced. And the legal concerns, I think, broadly around privacy and data protection are common to all industries. And there are very entertaining cases. We're a technology provider, so we don't have to deal with them directly, but when one farmer contracts to fly over another farmer's property, that's an issue. When one telecom carrier wants to go and survey all of the other telecom carriers' towers and take pictures of them, that's probably another issue, and we've encountered both of those, just thankfully indirectly.
Okay, we only have a few minutes left, so I'm going to jump to the last two questions of this slide. Flash forward 5 years, where do you think the industry will be? Do you foresee a legal evolution promoting the use or conversely restricting the use of UAVs?
I would say in 5 years, I think UAS is very normal, and I don't think it's as sexy as a topic. I think it's what people do. It's another form of robotics, and from a legal perspective, hopefully we don't see any incidents where people get hurt, but it's probably going to happen, and if it does, I suspect we'll probably see some repercussions from that. But in the end, I think that would help the industry and make it healthy, because ultimately that type of regulation and reaction is going to be what really drives industry to best performers and safest performers. So that's what I see.
Now, I agree.
I
think if there is a problem, it's going to come on the consumer side. The FAA has laid out a framework where if people are responsible and follow the rules, we're going to have a very safe environment. I'm a little bit pessimistic about that happening across the 2 million users of $500 to $1,000 UAVs. So I think in the commercial space, you're going to see very broad, very pedestrian deployment widely of UAS. I think the consumer space could actually see tighter regulation based on the outcome of the masses' behavior over the next 5 years.
Yeah. I second that. I would say 5 years, flash forward, from a commercial perspective, it will be the routine or the regular way we perform business and do inspections. I think, the Googles and the Amazons and the FedEx companies of the world will be able to have more, will be able to use that, and it will help change the culture of our people. So it will no longer be a shock. But I agree with Eric, from a legal evolution, I see the biggest risk with our hobbyists, with our children using them as toys, with them exploring, having fun, not necessarily knowing what's right or wrong. Eventually somebody will likely get hurt. Somebody will likely fly into some sort of building or infrastructure, and I would expect that there would be some more regulation around hobbyist users and commercial users. From a commercial perspective, we want to follow regulation, so we welcome it, and we'll follow the rules. So that's, for us, it's not an issue, but for the hobbyists, I think it will be a big issue.
Okay, thank you. We have a quick couple of questions. I'm going to try and condense them into one. For the agribusiness products, services that you are you encountering any barriers to adoption by growers that are unfamiliar or biased against new technology or UAS? And similarly, well, not similar, kind of conversely, how deeply has UAS penetrated the ag industry?
Oh, I think we have pretty good statistics on that. It's right now less than 1% of growers that have UAS, and UAS is reaching less than 3% of acres in any way. I do think, Jamie showed a video of, how easy it is to use UAS, and I look at that and it's, this is quite terrible. We're still making users pull out the USB drive and look, I march over to my office and I plug it in here and I bring it over here, and then I can plug it into some bizarre looking controller, and that's all gotta go away if we're gonna see the kind of uptake that they saw with, self-driving RTK-based systems. It's just too hard. We're asking too much of users today in agriculture.
Is there a way that you're marketing to the growers to address their issues?
We're trying to make it as easy as possible. So it's, John Deere provides us with field boundaries, like I said, gets automatically uploaded into the app. They go through a 4-hour safety training class, and they should just hit the field, hit the button, and then their portion of the work is done.
Okay. Well, thanks again for joining us today. We hope you learned something that you can take back to your company. Just a reminder, if you need CLE credit, please fill out the form that was either sent to you yesterday if you're joining via webinar and return it to Dorsey, or sign the green sheet if you are here in person. In the next day or so, you'll receive a very short survey, and we would like to hear what you thought about this program, and would like to hear your thoughts on what you would like to see in upcoming programs. We take your comments very seriously and use them to improve our programming at Dorsey. The Food and Agribusiness Industry Group provides several webinars and live programs each year on industry hot topics and other practical law changes that affect you and your companies. We hope that you will join us for future programming. If you have any questions concerning today's program or other food and agribusiness industry matters, please do not hesitate to contact us. Thank you.
Hey, DJ, this one, get a card. I don't know.